Okay, so in this video, I'm going to show you how to design your motorizing project. Okay, so first of all, we're going to our classroom, and inside our classroom, we have lots of work to do, but we have the reading project. We go to the reading project, and here in Archivideac, you have the new Da Vinci machine design. We pick on it, click on it, and we can't see it, but we can download it. Okay, we download it. It will say, where do you want to download it? Or in Descargas or something like that. And I'm going to tell him to make it in the desktop. Okay, I have it there. Now I'm going to Tinkercad. Okay, this is Tinkercad. You can Google it, Tinkercad. And I'm going to start the session with Google. So I'm going to use the school Gmail. Once we have the school Gmail, it will enter our session, and there we can see different things, our different designs. Okay, so I'm going to make a new design. New design. Okay, let's give it a little bit of time. Okay, and now I'm going to import and select. Okay, here we have where it is Da Vinci Machine Design. That's it. We import it, and here it is. Okay, is it? This is a representation of your works. Okay, any work you have, this part is the same, and this is the axis you have to put in movement. Okay, you have to motorize this axis. So first of all, we have to locate the motor wherever you want. Okay, so what I'm going to do, I'm going to put a cube. I'm going to take a cube, and I'm going to change its measures. So I'm going to put this will be 50, this will be 15, and this will be 15. Why? Because you have 15 by 15 pieces that you didn't use in your project, so you can put them somewhere like this. Okay, somewhere like here. Okay, but not like this. I'm going to put it like, wait, oh, sorry. I'm going to no and do. I want to move it, and here now. That's it. 90. No, no, 90. That's it. Now I'm going to change the view to be able to make it correctly. Here it isn't, but here it is. Oh, no. I think that's it. Okay, so I'm going to put this here. Okay, I think you had another one even. So I'm going to take another one. No, I'm going to copy this. Copy and paste. And I'm going to put it here. Now I'm going to make a zoom and put it here. Okay, now I take this, but you can make this wherever you want. I'm just picking this point. Okay, you take this and you group it. That's it. now I have this design. And now here, I'm going to put a cylinder. Oh, not a cylinder. What a cylinder. What cylinder are we talking about? Not cylinders, please. I'm going to take here components, circuits components. And here I have a motor. Okay, you have a motor here. We just are going to rotate it 90 degrees. We're going to get it up 50 millimeters. And we're going to put it here. Okay, you see? So now I have this axis and this axis which we have to connect, and they are parallel. So now I have a ruler. I'm going to use the ruler here. No, wait. It's we have this piece. We have this piece, and we have the ruler respect to here. Oh no, didn't pick the correct point, you see? So ruler, we take this and pick the ruler respect to this point. It will be easier. That's it. Now we have 30 and then 22.5. So we are in the middle of this. We know that from here to here we have, this is 152. So we have 75. Okay, so we take calculation and we have 75 to the middle. Now we sorry, we have 75. Now we have 30 and the half of 22.5. So 30 and 22 divided by 2. Oh, I used a point, not a comma. So, and now the distance will be 75 minus 30 minus. So the distance is 33.75. Okay, horizontally. Vertically, I want to z. Okay, so vertically this is 130. So vertically this is 130. And we have 15 and then 38, but I need to know where this is exactly. So, oh, it's just in the middle. Oh, we have a problem in here. Why? Because we have this spot. Okay, we are going to calculate it like this. And then if we have to adjust it, we adjust it. But the project will be made with this motor, okay? So 38.21, 15, and 38.21 divided by 2. So this will be okay. So these are the distances, horizontal and vertical. So as you are very clever, you are capable of knowing the real distance between these two axes, from this axis to this axis, using Pythagoras. Okay, so you can make this multiplied by itself. You can make this multiplied by itself. you can add the two of them, and you can make a square root of this value to know which is the distance, which is 101.66 millimeters. Okay, so what we are doing is what happened here. Okay, this. Okay, so what 101.66 millimeters is the distance we have. Now we have to think of a solution with this distance. Okay, if we are using polys, okay, we are using, let me look it in Google. If we are using polys, okay, uh, we are using polys, we can pick the, we can come here and take wherever we want, just cylinders, and simulate them, okay? But we have to think that we have a mechanical advantage. We want a mechanical advantage of at least 4 or 5. So if we want the strength to be 4 times bigger, we'll have a big poly and we have a small poly, okay? And the big one's diameter must be at least, so if I pick one of 50 millimeters, the other one must be of 60 millimeters. Why? Because it's 4 times bigger, it will rotate 4 times slower, so the force will be 4 times bigger. Okay? That's it. I can't make it. At most, I can make it from 20. Why? Because this will be 80. Oh no, it could be from 40. This will be 160. So the radius will be 20 and 80. So it will be almost touching each other. Okay, this is the biggest I can do. Okay, this is quite small. 15 millimeters is very small. So I can take something like 30 and 120. So the distance between them is 15 and 60, 75. So we have 35 millimeters. And this would be quite okay. Yes, so for example, I could design something like this. I could make them, just let me change this because it will be a little bit strange. The height I'm going to put just 10 millimeters. I'm going to put it, I'm going to make it 30 and 30. Now we're going to rotate it if we can. 90, okay? Now with that, the height of this was 34.105. But I have to 15 less, so 19. The height will be 19.105. If I move this, it should be just in the middle of. Okay, this should be the first one. Is it? And now I'm going to take another one and make it 10 millimeters high and now we said it was about 120. 120, 120. Okay, now we rotate it, and now we get it up. How much? Okay, so it's 60. It must be 75. No, not 75. The height is 130, and I have 60, so 70 millimeters. This will be 70. Now I move it. Where are you going? Come here. Okay, let's move it. That's it. Let's. Oh, not in the middle. Okay, I'm going to do it more or less, but you have to look that you put it in the middle, okay? So this will be one of the possible designs. Then we have to put something to make the connection between them. For example, a rubber, okay? And this would be it, okay? Now you don't go and copy this design, please. Okay, and what we have to do is print 3D this and this, but you should make something like inside here to put to put to make room for the rubber or something like that. Okay, if you are going to make gears, it's more difficult. I don't know if I have gears here. Let's see. Connectors, connectors, connectors. No. Let's see if shape generators. No. Let's see circuits. Oh, this is for making them components, more electronic oriented. Yes. Printables. Okay, so we should make special gears for us. You could always 3D gear STL. If you look for them, you can find 3D gears for you to make. But first of all, we should calculate. We have this distance, so this is for pulleys. But if we want gears, we must be very, very exact because the good thing about pulleys is that the rubber makes the connection, so we don't need to be very exact about it. Okay? The gears are much better to carry the power, but the bad part is that the distance must be very exact for them to be able to gear, okay, to grind. The gears must grind with each other, and it's very difficult to achieve it if we are not exact. So here we have a problem that we are going to take, for example, the same, well, now we are going to take 5, okay? So we have a big gear and a small gear. But this time we need to make another thing. So the distance is this, okay? So if the distance is this, we need to make this diameter will be d, and this will be 5d. Okay, so the radius the radius of these two, the distance between these two, will be 2.5 times the diameter and half. So 2.5 is 3 diameters the distance. And this must be 101.66. So the diameter must be, okay, this we can do. So we can do this like, we must be very exact, but not madly exact. Okay, so 3D 102. That means D must be 102 divided by 3, which is 30, 30, how much? 34 millimeters. Okay, so this should be 34, and this will be 5 times this, which is 170. So the distance between them is this and this divided by 2. So 102. Okay, if you want, you can relocate this motor 1 millimeter this side for this distance to be 102 exactly. Okay, that you can do. You can relocate the motor so the distance is better for you. Okay, so we have this, we have this. Okay, and now we have to make that we have a 34 millimeter gear and 170 millimeter gear. Okay, so we should go here, 3D gears as tell file for 3D printer gear. Let's see. 3D gears. Oh, they're charging for them. Free, 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 please. Free gears. Okay, so I said free. Let's see. Okay, let's see. Let's download this. Oh, you have to sync up. Sync up. So, okay. You can try to go back. Okay, here, for example. Okay. Well, you can look if you can find, okay? I didn't have time to make it, so I'm just making it up now. Uh, let's see. This should be more or less it. And I don't think there's more to say. I think you can understand with this. You have to put all the calculations, explain them, and make some croquis based on this. Okay, you can take photos from this. Okay, and explain to me how you are going to do it. Okay, then if you can't find gears, if you choose gears, or if you can't find the pieces you want, just tell me and I'll help you find them. Okay, so that's it. Thank you very much.